everyone. I'm Mitsani Kavindi, an undergraduate student at LNBTI University. Today we are diving deep into heaps, an important data structure in computer science. By the end of this video, you will understand max heap, min heaps, heap properties, and complete binary tree. We will also implement heaps in Java, covering insertion, deletion, and Heapify. So let's get started. A heap is a complete binary tree. In a complete binary tree, all levels are completely filled except possibly the last. And the last level is filled from left to right. And each non-leaf nodes has exactly 2 child nodes. So here we have 2 trees. This one is completely binary tree. And this is not a complete binary tree. In a tree, we have root node and parent node, child nodes and leaf nodes. And this is not a complete binary tree because there are only one children node in those parent nodes. It is necessary to have 2 children nodes in the parent nodes. And this is not the last level, so this level is not completely filled. Therefore, this is not a complete binary tree. Now let's discuss about the heap properties. There are 2 main types of heap properties. First one is max heap, second one is min heap. First we will learn about max heap. In the max heap, the parent node is always greater than or equal to its child nodes. In the max heap, the parent node is always greater than or equal to its children nodes. Let me show an example. This is an example for a max heap. Let's get this subtree. Here, this parent node is greater than its 2 child nodes. Also, in the below subtrees, parent nodes are always greater than its children nodes. So this is our second type, min heap. In the min heap, the parent node is always lower than child nodes. Let's see the example. As you can see, every parent node is lower than the relevant child node. Okay, let's sort these values into a min heap. First, we have to take the first value as a root, like this, and the second value is going to be the left child, and the next value is 5. In here, this is not a min heap. Therefore, we have to swap these 2 numbers. After swapping these 2 numbers, our root is 5. Then we have to add 25. Then 30. And then we have to add 15 and then add 8. In here, this is not a min heap, So we have to swap 10 and 8. Okay, this is a min heap. Every parent node is lower than its child nodes. This process is called Heapify. In the heap tree, we have two operations. First one is insert operation and second one is delete operation. Let's do the insert operation to the max heap. Here we are going to insert 60. So we are going to add 60 to here. Because when we are adding new element, we have to add it from left to right. Here this is not the max heap because 60 is greater than 15. So we have to swap these two numbers, or we have to heapify this tree. After swapping these two numbers, we can get the tree like this. Again, this is not the max heap because 30 is less than 60. So again we have to heapify this tree. After swapping these two numbers, we can check whether this tree is max heap or not. As we can see, 50 is less than 60, so we have to swap these two numbers. After swapping these two numbers, we can get max heap tree. As you can see, every parent nodes in this tree is greater than its child nodes. This is how we are going to insert value to the max heap tree. The second operation is delete operation. Here we have max heap tree. When we are doing delete operation, we can delete only the root node. This is same as pop operation because we can delete only the top value of this tree. After removing the root node, we should replace it with the last node. In this tree, the last node is 16. So after deleting 50, we have to replace it with 16. So we have to check whether this is max heap tree or not. As you can see, the 16 is lower than 30. So we have to swap these two numbers. After swapping these two numbers, we can get max heap tree. As you can see, all parent nodes in this tree is greater than its child nodes. So this is how to delete operation used in max heap tree. Next we will see the Java implementation.
This is our code implementation. Our first step is define the heap class. This class implements a max heap using an array. Here we have three variables that used in our constructor. This constructor to initialize the heap with the given capacity. And our second step is insert operation. This method insert a new element into the heap while maintaining heap properties. This heapify up to maintain the max heap property. And this helper method to swap two elements in the loop. Our third step is delete root operation. This method removes and returns the maximum element from the heap. This restores the heap property by heapifying down. And this helper method for heapify down operation. Here we have three if conditions. First if condition check if the left child exists and is greater than the current largest element. And this check if the right child exists and is greater than the current largest element. And the last if condition checks if the largest element is not the current index, swap and continue heapifying down. And our fourth step is build a heap from an array. This function converts an unstored array into a heap in 0 into n time complexity. And this heapify down for each non-leaf node to build the heap. Our next step is heap the sort implementation. This method sorts the heap using heap sort algorithm. This helper method to display heap elements. And our last step is testing the heap implementation. This class contains the main method to test max heap operation. First, we create the max heap with a capacity of 10 and insert these values to the heap. Now let's execute and see how this works. As you can see, the output displays heap elements, deleted elements, heap after deletion, built heap, and the sorted array by performing heap sort. And that's how the heap class works. If you have any doubts, please pause the video and read the comments of the code since I have added necessary explanation of each code line.
And that's it. We have covered heap properties, max heap versus min heap, heap operations and Java implementation. Now you have everything you need to start using heaps in your projects. If you found this helpful, like, share and subscribe for more data structured tutorials. See you in the next video. Bye.